Dear students, this video I explain the example problem on direct decomposition method or direct programming method. Consider the example like this. The transfer function, given transfer function is equal to 5s square plus 6s plus 8 divided by s power 3 plus 3s square plus 7s plus 9. So this is the transfer function. Decompose the denominator as already I given an example like that. Therefore, decomposition of denominator as below. The given denominator is s power 3 plus 3s square plus 7s plus 9. So this can be written as s plus 3 into s plus 7 into s plus 9. Like that we can split or we can program the denominator. So s plus 3 into s plus 7 into s plus 9. So denominator is programmed. Now draw the diagram for initially s plus 3, after into s plus 7, after into s plus 9. So the simulation starts from s plus 3 in denominator. So that this is the diagram for only the denominator. So first draw the s plus 3. So 1 by s plus 3. Denominator in the sense 1 by s plus 3. In denominator s plus 3 is nothing but 1 by s plus 3. That means so that summation, integration and one feedback. Only this one. This is nothing but s plus 3. One integrator, one feedback, and this is the negative feedback, so that minus is integrated. Minus is indicated. So that up to this part, what we have to complete, this s plus 3 is complete. And again 1 into s plus 7. That means we can expand the next part. So what we have to do, one integrator is connected in series and one feedback block is connected to the summation. So that 1 by s and the value is 7. Here the value is 7, so that the block filled with 7, and this is also negative feedback, so that minus indication. And once again we want to expand into s plus 9, so that once again one integrator is added in series and one block is added in feedback. The feedback value is 9, and once again this one is negative feedback, so that third integration and third block is added, and this is also negative feedback. So that this is the total diagram for the denominator only. This part is only for first one, that is s plus 3, and into s plus 7 up to this one, into s plus 9 up to this one. Already I explained. So next step we want to added, that means integration is added in series and the block is added in feedback. So that like that we can expand n number of blocks. So up to now the denominator part is completed. Now we go for the numerator part. So numerator part consisting of, so this one, numerator is this one. That means 8 not multiplying with any s, so that 8 is directly connected to the output. 6s, 6 multiplied with 1s, so that 6 block is connected before one integrator, and 5s square, 5 multiplied with s into s, 2 s's will be there, so that 5 block is connected before 2 integrators. Like that we can connect the numerator. So this is only the denominator, this is numerator. So that up to now, so integrator and block, integrator block, integrator block. So this one is denominator part. Now I want to add the numerator, so that 8 is directly connected to the sum output summation. Why? Because 8 not multiplying with any s, so that 8 is directly connected, and 6 multiplying with 1 s, so that 6 is connected before one integrator, and 5 is multiplied with s into s, 2 s's, so that 5 is connected before 2 integrators. This is one integrator, this is second integrator, so that 5 is connected before 2 integrators. So numerator is completed. So this is the total required diagram for direct decomposition method for a given state model. So now we can design the equations and finally we can write the state model. So from this diagram we can write the equations. So state equations and output equation. Already we know each integrator output is one state variable, so that this integrator output is x1. If this integrator output is x1, input is definitely x1 dot of t, and this integrator second integrator, so that output is x2, consider as x2, and if the output is x2, integrator definitely x2 dot of t. Why? Because what the integrators do, only the eliminating denominators or differentiation, that's all. X2 dot of t is nothing but one time differentiation of x2. The differentiation is eliminated by using this integrator. We can get x2 denominator, sorry, differentiation and integration is cancelled, we can get x2. So this integrator output is x3, definitely the input is x3 dot of 3. So these are the, now we can consult the equations. X1 dot of t is equal to, so x1 dot of t is nothing but x2. There is no incoming branch here, only x2 is there, so that x1 dot of t is equal to x2, and x2 dot of t is equal to x3, and x3 dot of 3 is nothing but this summation output is nothing but x3 dot of t. That means u of t minus, so this summation minus 9 multiplied with x1, so that u of t minus 9 x1 of t and minus 7 x2 of t minus 3 x3 of t. These are the equations for x1 dot of t and x2 dot of t and x3 dot of t. And output equation y of t is equal to this summation output is y of t. That means summation one input is 8 multiplied with x1, so that x8 into x1 of t and 6 into x2 of t and 5 into x3 of t, all are plus values, so that all are added. So therefore these are the equations. X1 of t is equal to x2, x2 of t is equal to x3, x3 dot of t is equal to u of t minus 9 into x1 of t minus 7 into x2 of t minus 3 into x3 of t, and output y of t is equal to 8 into x1 of t plus 6 into x2 of t plus 5 into x3 of t. So from these equations we can write the state equations, that is state equation and output equation. From these three equations we can write the state equation. From this equation we can write the output equation. The basic format for the state equation is x1 dot of t is equal to a into x of t plus b into u of t, and output equation y of t is equal to c into x of t plus d into u of t. We can write a matrix, b matrix, c matrix and d matrix. So these are the standard formats. By using these formats we can write the matrix A. So from these three equations we can write the matrix A. So first column of the matrix, x1 dot of t is equal to only x2 is there, so that x1 term is not there, x3 term is not there, so that A is equal to 0 multiplied with x1 plus 1 multiplied with x2 plus 0 multiplied with x3, so that 0 1 0 x1 dot of t. X2 dot of t is nothing but second row, only x3 is there, x1 is 0, x2 is 0, only x3 term is there, sorry, x3 term is there, so that 0 0 1, and x3 dot of t is equal to, so x1 multiplied with minus 9, x2 multiplied with minus 7, x3 multiplied with minus 3, so that minus 9 minus 7 minus 3. So this is the matrix A. Now we go for the matrix B. So B matrix multiplied with u of t. So here x1 dot of t not having any u of t, so that first value is 0. X2 dot of t not having any u of t, so that this value is 0, and x3 dot of t having 1 into u of t, so that this value is 1. So B matrix is completed. So that A and B matrix are drawn from this state equations, x1 dot of t, x2 dot of t and x3 dot of t. And out from the output equation we can design the matrix C and D. C matrix already we know the row matrix, this one is the row matrix. So y of t is equal to x1 multiplied with 8, x2 multiplied with 6, x3 multiplied with 5, so that 8 6 5, and there is no u of t value here, so that d multiplied with u of t term is not there in the output equation, so that d value is 0. So this is the output equation, this is the state equations for a given state model by using the transfer function. If a given transfer function, that is direct, by using direct decomposition method or direct programming method.